Hello everyone, and welcome to the first video sequence. We will be shown the integration of Mentor's DxDesigner and PCB Expedition with Oracle's Agile PLM. The integration is executed from the Tools menu within DxDesigner, and there are a set of functional modules here which can represent various integrate functions. Some of these functional modules will be shown in the demonstration and others will be just mentioned. In this demo scenario, we start with the creation of a new project. This is done by the Integrate To function called New Project. Here we switch automatically to the Integrate To environment, and thus the new project process is now running. When this function is executed, the user is presented with a graphical user interface, showing him various options for creating a new schematic and PCB design. In this demo, we can enter a new project name. Here we will use Agile PLM project. And the user can select different sources to create his new project. There are actually 4 options for selection of project source. The first option is to use an existing design. This design will be copied with a new name, and all references to Agile PLM will be erased. The next option is to take an existing design which has been created into PLM. In this case, the project will be downloaded from and then assigned a new unique name in the target project directory. The 2 last options are to create the initial design out of templates. In this demo, we will use templates located on the file system. We assume at this point that the designer already knows how many layers his PCB has and what size schematic drawings he requires. In this case, he selects a 2-layer PCB and size SKI schematic. Another option is to select a template from PLM. The advantage of this approach is that these PLM templates can be versioned and managed centrally, so anyone can track the source of a design template. In this case, we will show the creation of a project from schematic and PCB templates. We click OK and the new design creation process is started. Once the process is complete, the project is opened in DxDesigner. In this demo, the template we use is a design which already contains design information. We also have the same for the PCB. The PCB already contained physical design data, so I'll start Mentor Expedition PCB to show that it is there. It must be said that Integrate To supports several options for design creation. For example, there are different options or workflows. For example, the design engineer can create a design where there is nothing yet in PLM. Alternatively, some items must pre-exist in PLM, like assembly items. Another possible flow is that the design is only started with a schematic and then the PCB is subsequently added to the design. Okay, this concludes the new project creation process. Now we move to a functional module which pushes all the data to PLM. The module is called Save and it is used to perform a number of tasks. The main tasks include checking and conducting design information transfer to PLM. In particular, it saves schematic and PCB design data to PLM for later design reuse. It also creates assembly and manufacturing data from PCB design. It reads BOM information from the schematic and PCB design and then saves it to PLM. In this execution, we will start by pushing the design to PLM and uploading the BOM. We will also create a complete data model which we can examine later. On the top here we have the innovation document, which is represented by the design object in Agile PLM. The next item we have is a PCB, which stores the PCB manufacturing data for the bare board. It also represents your board in the bill of materials. The third and last item is your list of assemblies. In the current demo we have just one assembly which is created by the current design, but you could also have assembly variants in your design, so you could actually have a list of assemblies here. In this case you would be able to create different BOMs for them and to create different assembly data like top and bottom assembly plots, pick and place files and so on. We click Create. Here the various files to be saved are being generated and assembled. We can see these in the execution protocol window in the lower half. For now we will start with just uploading a design and creating a schematic PDF, and we will make BOM into our assembly. We click OK and subsequently the data model is created in PLM. This means that parts and design objects are being linked. After that, metadata is saved to the schematic design, and then the extraction process starts. Now the save module creates a schematic plot and a zipped container of the schematic design and the PCB design. Now the files that were created are being checked into Agile PLM. Now Integrate 2 reads the BOM out of the schematic design and searches for the parts which are present in the BOM in Agile PLM. What Integrate has done is to read the BOM out of the project, and using PLM data it compares the two BOMs and generates a BOM comparison report. The BOM comparison report shows which actions will be performed by Integrate 2 for a specific BOM. At the moment there is nothing yet in PLM, so all the entries here are green, meaning the components are new. It means that all of them will be added to PLM except those components which are listed as missing. The BOM comparison report has several tabs to simplify the analysis for the design engineer. The first tab is the reference designator based view, which gives one reference designator per line. The next tab is the quantity view, which is a part number per line view. This is actually the view that would be shown in an Agile PLM. There are also additional report views which are missing parts, the parts which do not exist yet in PLM. We will cover these parts a bit later when we look at synchronization of purchased parts. There is a special report for parts which are not yet released. They are either in a preliminary status or they may be obsolete, and so on. There is a report for unassigned parts which do not have a part number at all. In this demo design, this is not the case. Additionally, there is a tab which shows which parts could be reused in your mechanical integration. These are the parts applied to mechatronics. Additional reports can be configured here. After the design engineer has reviewed the changes that will be done to his BOM in PLM, he can press OK to confirm. We see here a validation one to say that parts are missing. In the demo scenario we can confirm this is OK, and we will save the data as it is to PLM. The BOM is actually being uploaded to PLM right now. After the save module has completed, we see that in our design project the metadata has been updated. The number of a design object is stored, and also the name of the design object is stored in the drawn frame properties. The set of metadata which is synchronized between PLM and your design project is configurable. For example, we can annotate here the PCB number and the number of the top assembly and so on. Now we can go to Agile PLM and see what has been created there. Here we are in Agile PLM. We will search for our design object, Design 18. we will look at its relationships. But under Files, the design object holds a schematic PDF and an innovation container as attached files. And the design object has relationships to PCB part and an assembly item. On the BOM of the assembly item, we now have a small BOM of components which are listed here. We're able to go to the design object and view the schematic PDF files. This is viewable in Auto View. Here we have the design being loaded. We can also look at the schematic design using Agile Auto View. Okay, this concludes the current video sequence for Save module. Usually after we invoke a new project, we get a blank design with just a couple of schematic sheets and drawing frames with an empty PCB with some settings. But in the current scenario, we already have a design populated with schematic data. We can take a look into that. We can also open the PCB in Mentor Expedition to look at the physical layout. We see here an initial board created for demonstration. The project has a library configured and also has two assembly variants. One is the base variant and the other is the extension of the base variant. So now we can turn to the functional module, which is used to push the data to PLM. The module is called Save Project. Here we are in the Integrate To window in the Save or Design Push process. On the top half of the user interface, we see three kinds of items. These items are used to store the design data in Agile PLM. The first item, right at the top, is an innovation design object. This object will store all the design data. The next is a PCB item, which represents 3 bare boards and holds Gerber files, drill drawings, manufacturing drawings, artworks, and so on. At the bottom we have items which represent assembled boards. These items naturally have bill of materials and also store assembly information. Since we already have data in our design, we can immediately push all the data to Agile PLM. I will select only one of 2 variants in order to make the upload faster. I deselect the second one here. Additionally, it should be noted that I used the option Update All, which means all of the items will be created in the data model in PLM, and all checkboxes will be set by default. I will run Design Push now by clicking OK, and let's see what the process is going to do. It performs numerous actions. Now it is creating links in the data model in Agile PLM and saves the metadata of items back to your design. It is creating schematic plots and exports a zipped innovation container. It creates a BOM from your schematic design. It also creates Gerber data, artwork plots and drill plots from your PCB design. Now the previous BOM has been read from Agile PLM and from DxDesigner and Integrate searches for used files in PLM. Integrate compares the BOMs between DxDesigner and Agile PLM, and it will shortly generate a BOM comparison report. After the BOMs are compared and the report is displayed, it uses a color code to tell the designer which components are added, which are changed, and which are removed in his design. For now, all components appear green, indicating that all components will be newly added to Agile PLM. The BOM comparison report has several views or analysis perspectives. The first is the reference designator view, which has one reference designator per line. The second is Quantity View, which lists part numbers per line and the quantity of each component type. It also has a number of configurable reports like missing parts or parts which are not yet released, but they do exist in PLM. We also have part numbers which do not have a part number assigned. Also, we have part numbers which can be used in connection with a mechanical system. To confirm that you are happy with the comparison report and to continue uploading the BOM, you click OK. In this case, we see a warning that parts are missing in your design. This means they exist in your design but have not yet been created in PLM. Often this is a fatal error and we may not want to upload the BOM, but in this demo scenario we will perform the upload. We click OK and the upload is started. The upload process takes a few seconds. After the save module was completed, we can look to see what was created during the execution. First of all, save stores some metadata of PLM back to the schematic for reference and for creation of PDFs. If we zoom in, we can see the drawing number of the design object. It should be noted that metadata which is synchronized back to your design is entirely configurable, and it depends on the customer's requirements as to which metadata appears here. For example, it could be reference to different items in the data model, it could be revision history, and so on. We will now go back to PLM and take a look at one of our assemblies. It has been created as an introductory revision from Integrate. Under Relationships, we can see that it has a BOM. On the first line, we have a link to our bearboard, which we will look at a bit later. The next lines are the components used in the design. The assembly has a relationship to a design object which stores two files. There is a schematic PDF and a zip file or innovation container which holds all the design information. We can view the schematic PDF in Agile Auto View. We can see that metadata is already synchronized to the drawing frame of the schematic. Then under Attachments, we see our assembly has several attachments, the first of which is an assembly plot file. This is typically a top and bottom plot of the PCB. The next attachment is a variant schematic plot created out of DxDesigner. And the last attachment is a file that contains assembly data, the data which is required to assemble the board. In this case, this is just one file from Expedition PCB, but the file definitions here are configurable according to user requirements. Now let's go to our PCB item at the top here and see what we have. The PCB also has a relationship to the Agile 9 design object, and it has attachments which include a folder which contains Gerber files, a file folder with Gerber files, and a manufacturing PDF which is a drill drawing in this case. We can open this PDF in AutoView to check what exists there. Now, before we continue with integrate functions, let's discuss how purchase parts are synchronized between your company library and Agile 9 PLM. Integrate 2 supports a number of different options, including unattended updates of the library from Agile PLM based on a workflow trigger or a batch procedure which runs at regular intervals. One option is interactive synchronization of purchase parts between DxDesigner and Agile PLM. For that, we have a functional module called Synchronized Parts. This process is highly configurable with respect to what is the desired workflow and who is responsible for the creation of new parts in the organization. It also depends on whether the parts just come from the ERP system, then electronic properties are set by the librarian. Alternatively, all the data could be set in DxDesigner, then synchronized back to Agile PLM. In this demo, it is assumed that the part is first created in Agile PLM, and properties are created in Agile PLM, and then synchronized to DxDesigner and DxDatabook. When synchronized part is started, the user sees a class selection interface. Usually it corresponds to Agile PLM classes or DxDatabook tables. For now we will select only capacitors for synchronization and press Next to search for capacitors in Agile PLM and DxDatabook. What we see now is a part selection window, so if the engineer knows what part to synchronize, he can select a specific part or a number of parts. In this demo we have prepared this part for synchronization, and we can take a selection of other parts just for illustration and reference. So these parts would be selected for comparison, and we press Finish to continue. Synchronized Parts uses color coding to help the user identify which components exist in PLM only, or exist in DxDesigner only, or are somehow different between the two platforms. Here we have one part which is coded red and is therefore only in Agile PLM, and we have three parts which are only in DxDesigner. So what we will do now is to synchronize this Agile PLM part to DxDatabook. We invoke Synchronize and see that the information is transferred. So we see that in DxDatabook that the field voltage is numeric, while in Agile PLM it is a string field. Let's synchronize some other parts to Agile PLM. We see that a new part which has been created has acquired a new Agile PLM ID and now is in a preliminary status. We will now go back to DxDatabook and see what new part has been created there. So we are back in DxDatabook and we can search for our new capacitor. We will select Like Criteria. On the top we have the new capacitor. It should be mentioned that in this case we are using links to symbols and footprints only as string fields in Agile PLM. In some levels of integration, symbols and footprints can be represented as separate objects in Agile PLM. In this case, the reference to a symbol or footprint would not be a line on the properties of the Agile PLM part, but it would be a reference to an actual symbol or footprint. Later we will use this capacitor when we modify a design after release. After an extended development time consistent of many executions of the Save module, the design will be finished and all the items will be released into PLM. There may, however, be a subsequent need to update this design. To modify a design, a change request is created in Agile PLM, which includes all the items in the design data model affected. When the design engineer gets a notification about a change in his inbox, he executes an Integrate To module called Change Project. This process takes the design data from PLM back to his working environment in DxDesigner. He searches for his design object in Agile PLM. He finds his most recent version and selects it to check it out. The Change Project module unpacks the design data from PLM and updates the data model to the design. After that, the designer can now perform the change required. In this case, we will just place a new capacitor, but first we need to locate it. After the designer has placed his capacitor to his design and he may have also made some changes to the PCB, he runs the save module or save project once again. Now we see that instead of introductory, we have an ECO number and a new target revision. Since we only modified the schematic, we will only upload assembly data, including a schematic PDF and a BOM, so that we can see the differences compared to the previous revision. Here the data model has been updated. If we look at the BOM comparison report, we will see some changes. We see that the PCB is changed from prototype to status preliminary, and a new revision is created for the PCB, and this revision will be used in the BOM. We also see that a new capacitor, which have been added to the design, will be added to a new position number. We will press OK now and continue uploading the BOM. Now Integrate has uploaded all the BOM data and created the assembly plots and the schematic plots. The save module has been completed, and we can now go to Agile PLM to see what has been changed there. If we look at the changes in Agile PLM, we see that there are changes in the data model items and in the assembly. We can also see that there are red items in the assembly BOM, and our new component C99 is added with a new reference designator, and it goes into a new position. If we go to the Attach tab of our assembly document, we now see that the file folder, which contains file names which have the ECO ID and the target revision included. And we can see that the folder contains the schematic plot. Now there are two versions of the file folder. We see that in version 2 that the file now contains the ECO number, while version 1 is introductory. In succeeding versions, the new resource will be used. We can compare the versions visually using AutoView. We will invoke ViewCompare. So now we are selecting revision 2 and comparing it with version 1. Now in AutoView we will see that there is a difference in the design, and we have one additional capacitor which will be highlighted here in green. The same design differences can be highlighted between two Gerber files and two drill plots and so on. So this completes the change design sequence.